Hello and welcome back to another lecture. Today we are going to go over section 5.5, which is diving into negative exponents. This is in addition to the exponent rules that we've discussed previously. So I highly suggest, as before, having these exponent rules on a separate sheet of paper. That way you have them easily accessible. And this will be a rule that you just want to add to that list. So let's start with, what does a negative exponent look like? If I have the basic definition where I have some base raised to the negative m exponent, this will simplify out to a positive exponent that is reciprocated. So I have a to the negative m will be the same as flipping this a, or reciprocating this base value, where I have 1 over a to the positive m value. Likewise, you have another rule, that's a little and symbol, there you go. The other idea is that if I have a negative exponent in my denominator value, I can reciprocate this so that it becomes positive in the numerator. And so these two rules, these two parts of a rule rather, define how we can work with negative exponents and then make them positive. We like to work with positive exponents in our solutions because that means they are fully simplified. Now, with that being said, let's just try an example. So I have 3 to the negative second power. That is my first problem on the paper. 3 to the negative second power, let's start by making this positive. So I need to flip this 3, because currently it's over 1. Remember, any kind of whole value is always over 1. And so what I'm looking at here is this would be 1 over 3 to the positive second. Because I made it a reciprocal, it's no longer 3, but it's 1 over 3. This exponent then becomes positive. So I have 1 over 3 to the second. Now, again, if you have an instruction that says leave your response in with a positive exponent, this would be fine. If it says leave your response in simplest terms, or if it just says simplify, you want to go all the way. So 3 squared is 9, so this is 1 over 9 as your simplest form. What if I were to have a negative 3 to the negative second? Ooh, negatives, they're popping up everywhere. What do I do? Well, don't worry. This negative has absolutely nothing to do with this negative. In fact, because this negative is not inside of parentheses, this negative is actually completely separate anyway. So I have a negative 1 times a 3 to the negative second. Technically, that's how I can read this problem. So what that means for me is I'm going to simply invert my 3 to the negative second. That is my base, the 3. And that means I will have a negative from here, 1 over 3 to the second. 3 to the second, we said, is 9, so that is a negative 1 over 9. Pretty straightforward, just don't lose your negatives. Don't get up in a tussle about having multiple negatives throughout a problem. Let's try another problem. I have plenty of board space over here. It might help if I don't lose my place. There we are. So I have 6 to the negative third. So 6 to the negative third, again, my base is 6. I have a negative 3 power. I want it positive. That's 1 over 6 to the third power. Simplify that. Again, feel free to use a calculator as you're going through. But as you're looking at simplifying 6 to the third, that's 6 times 6 is 36, times another 6 makes it 216. So you get 1 over 216. What if you had 2x as a quantity to the negative 4th power? Well, the question is, what is my base? Because as I'm looking at this problem, my entire quantity is the base, right? So let's take this in pieces, kind of using those exponent rules together now. I have 1 over 2x as a quantity still to the 4th power. So I simply used my negative exponent rule. I inverted this problem so that I now have a positive exponent. Now I can use my power to a product rule. Okay, so what we're going to do is we are going to distribute this forward to each term. That is technically 1 over 2 to the fourth, x to the fourth. You can simplify 2 to the fourth. That's going to be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So you have 1 over 16 x to the fourth. So negative exponents really aren't too bad when you start playing around with their application within a problem. Now, that being said, you have to be very cognizant of some variations, kind of like that negative we saw in a previous problem. If I happen to have something like 2x to the negative fourth, very similar to what we just did, but there's a major difference. Here, my 2x was a quantity. Here, my 2x is not a quantity. So what is my base in this situation? Just x. So what that means for me is that only the x term, because that's the only one that has the negative exponent on it, only the x term gets inverted. This 2 does not get inverted. So I would have 2 over x to the fourth. So only the term, only the base that has the negative exponent will get inverted. Excellent. What if I had 1 over 4 to the negative third? Well, this is that other part of the negative exponent rule that you've already written down, or it's on your notes. What you're going to do is you're going to invert. You're going to reciprocate. So we are going to make this 4 over 1 technically, but that's 4 to the positive third power. And by doing so, you can now simplify. 4 to the third power is 64. Let's try another one. Let's say I have 1 over x squared y to the negative third. Now in this particular problem, what we're going to do is we're going to look at each base, because I have multiple exponents now, and I'm going to determine which base actually contains a negative exponent. Is it x? No, because this is a positive 2. Is it y? Yes, because this is a negative 3. So what gets inverted here? What gets reciprocated? Just the y. The x already has a positive exponent, so it will not move. So this will then mean I have y cubed, once it's reciprocated, over x squared. Excellent. Let's try a few more. Negative exponents is a very simple concept, but it can be very deceiving as you start getting many different components. So I just want to make sure we have a solid understanding. If I have 4 to the negative second, I'm going to invert or reciprocate my values. I will then have 1 over 4 squared, which is 1/16. Now, what does that look like if I have a fraction? I know those of you who are cringing because of fractions, remember, fractions are friends, not food. Now, that being said, you have 2/3 raised as a quantity to the negative second power. What do? Well, you're going to invert, because what you did here is you had 4 to the negative second. You inverted the 4, right? Technically, this was like 4 over 1, wasn't it? And when you inverted it, it became 1 over 4 to the second. Well, what if that second out here was there? How does that change my answer? Well, does it change my answer? 1 squared is 1. 4 squared is still 16. Huh. So you've already been working with fractions is what you're saying. Yeah. See what I did there? So we are going to invert and then use our exponent. So this becomes 3 over 2 to the positive second power. Pretty straightforward. You're going to invert and make it positive. Same exact thing you've been doing. Now, at this point, you can definitely look at this and distribute this 2 to each term. 3 squared would be 9. 2 squared would be 4. So you have 9/4 as a result. What if I had c to the negative second over c to the negative sixth? Interesting. I could start by inverting. You're absolutely right. Now, there's another thing. You have a quotient rule that you could use. Go back to your exponent rules. This is why you want them handy off to the side. But use that quotient rule. These are the same base. So I have c to the negative 2 minus, because you're in quotient rule, a negative 6. What is negative 2 minus a negative 6? That would be c to the positive 4th. Cool. So you can use exponent rules still, and you can also use your negative exponents. I'm going to show you the same problem using that negative exponent, just to be very clear. So I have c to the negative second over c to the negative sixth. That was my original. If I were to use my negative exponents, this c has to go down here to the denominator. Excuse me. This c has to be raised up to the numerator. Well, I'm back to quotient rule. 6 minus 2 is 4. Same thing either way. So it's beautiful how you can use exponent rules in combination. So I highly suggest utilizing your exponent rules where they fit the situation best. All right, let's jump to this problem. It's my pirate problem. It's full of R's. I know, very corny. I can hear you laughing on the other side. All right, so I have r over r minus 6, r to the negative 6th over, let's start by rereading that problem, because once I get on a roll, it is what it is. So I have r over r to the negative 6th times r to the negative 4th. That sounds much better. I see that I have negative exponents. I see I have a product rule. I also see I have a quotient rule. I can do a lot of different things here. So I'm going to simplify with product rule first. So I have r, nothing changed in the numerator. Down here, my denominator, I have the same base of r. Negative 6 plus a negative 4 is a negative 10. That's my product rule. And then I'm going to use quotient rule. Why not? So I have r to the 1 minus a negative 10, which is r to the 11th. Okay. Now, so far what we've done is we've looked at a combination of really using the negative exponent rules through here. We started looking at how you can use different exponent rules, starting with this problem of c's. And we kind of looked at how we can combine different rules within a problem. Now, as we're going through the final few problems, we're going to start putting our exponent rules in combination with one another. So this is definitely the point where you want to have those exponent rules easily available if you don't already. That being said, our first problem that we're going to start tackling, I have 12a to the negative 4th, b to the negative 2nd, over 6ab to the negative 2nd. The way you can approach this, there's a few different ways that you can approach this, but the way I'm going to approach this is I'm going to look at each individual component. 6 goes into 12 twice, that's a negative, so that is a negative 2. I'm going to use my quotient rule here, that's a to the negative 4th minus 1, and then b to the negative 2nd minus a negative 2. Okay, so I have negative 2. Negative 4 minus 1 is a negative 5, so that's a to the negative 5th once I simplified that. Negative 2 minus a negative 2 is like negative 2 plus 2, which is 0, so b to the 0. Now I'm not done yet. I see that I still have a negative exponent, and I also have a 0 exponent. Remember, anything to a 0 exponent is 1, so it kind of goes away. So this is a negative 2 over a to the positive 5th, just to make sure I have a positive exponent there. Excellent. Let's try another one. So I have a to the negative 8th, b to the 3rd as a quantity, raised to the negative 6th. Now, before I start working in here, just for this particular problem, I actually am going to distribute this negative 6. Could you have started in here and worked around? Absolutely. Absolutely you can. But I am just not going to, because these are just variables. I'm just going to multiply in. So negative 8 times negative 6 is a positive 48. Positive 3 and a negative 6 is a negative 18. This is my only negative variable now, my negative exponent variable. That means I have a to the 48 over b to the 18th. Okay. So problem-wise, these really aren't too bad. I got another one here. It just takes a lot of repetition, a lot of practicing, and that's true of anything in math. So looking at this particular problem, I see negative exponents, I see coefficient values, I see variables. We got it all going on. So I'm going to start by rearranging a few things, and I'm going to use my quotient rules to be able to combine those terms. Here's what I'm going to do. I have the same base of 3. I have 1 minus a negative 1, x to the first minus a negative 2, and then I have y to the negative 4th. So I'm just using my quotient rule to start combining all of my bases together. 1 minus a negative 1 is basically adding 1, so that's 3 squared. X, this is 1 minus a negative 2, so 1 plus 2 essentially is x cubed. And this y to the negative 4th still. I'm now going to simplify, so I have 3 squared, which is 9, x cubed. This y to the negative 4th is going to move down to the denominator and become positive. So that is 9x cubed over y to the 4th. All right. Let's move on to the next problem. Which is c to the 10th, c squared to the 3rd, c cubed to the 3rd, c squared to the negative 9th. Beautiful. All right. I'm going to start by using my power rule here. And the reason I'm going to use my power rule is so that I can start clearing some of these parentheses. It's just a little easier for me. So I see c to the 10th still, nothing changes. This becomes c to the 6th. I have c to the 9th and c to the negative 18th. I'm now going to use my product rule just to combine my numerators and denominators separately. So I have c to the 16th and c to the negative 9th. I'm now going to use my quotient rule. You could also use your negative exponent rule. But I prefer quotient rule whenever it's more convenient. So this is going to be 16 minus a negative 9, which is c to the 25th. Okay, let's try another one. This is 5a cubed for the next problem. A to the negative second as a quantity to the fifth. All of that divided by a to the negative first as a quantity to the negative second. So what we're going to do at this point is I'm going to use power rule first. Again, clear my parentheses out. So I have 5a cubed. Nothing has changed there. A to the negative second to the fifth is going to be a to the negative 10th. A to the negative first to the negative second becomes a to the positive second. I'm going to use my product rule in the numerator. That's going to be 5a to the negative 7th over a to the second. Now in this particular case, it's actually not more convenient to use a quotient rule. And the reason is, I see that my negative is in the numerator. I know I'm going to have an end result in the denominator. The key difference with using quotient rule, as you can see in this previous example, is that I knew my negative was moving up, which meant that my quotient rule would have given me a positive result in the end for my exponent. But here, it would have given me a negative. So I'm going to move using a negative exponent. So I have 5 over, this is going to be a squared times a to the 7th, which means I have 5 over a to the 9th. Could you have used quotient rule? Yes, you would have gotten a negative exponent, and then you would have had to move it down to the denominator. It's perfectly fine if that's the method you were wanting to use. Okay, I have 2 more problems for this section. Let's get some more board space because these are taking up some room for me. And here we are. Okay. Always have to keep track of where I am. This is k to the third, t to the fourth, divided by k to the second, t to the negative first. All of this as a quantity raised to the negative fourth power. Now, there's a couple different approaches that you could use here, and you wouldn't necessarily want to use one approach over the other. It's really just a matter of preference. So I am going to simplify inside of my parentheses before I go out to this negative exponent. And again, that's just a matter of preference. So I see that I have k to the third, k to the second. I'm going to use my quotient rule to get just k. I have t to the fourth, t to the negative first. I'm going to simplify that to get t to the fifth. So I'm again using quotient rule there. And this is still all raised to the negative fourth power. At this point, I will go ahead and distribute using my power rule. That's k to the negative fourth, t to the negative 20th. I have negative exponents, so I do need to invert both of these, and that is going to be 1 over k to the fourth. I don't know why I wrote a different term there. K to the fourth, and t to the 20th. And those are both positive now. All right, very good. Let's do this last problem. That is a k, if I ever did see one. So I have 4k to the third as a quantity times m to the negative fourth divided by the quantity of km to the negative third. So again, a couple different approaches here. I am going to use power rule first. That's just a preference here so I can clear my parentheses. So in this case, I have 4 to the third, which is 64. K to the third, m to the negative fourth, over This will become k to the negative third, m to the negative third. All right. Now I got a lot of working parts here. So if you want to stick to one method, you absolutely could. You could also just use quotient rule. You could use negative exponents. It really is a matter of preference. I personally will use the negative exponents, since that was the purpose of this section, just to show all of those working pieces. So I do have negative exponents in 3 different places. So I'm going to go ahead and keep my 64k to the third, which is positive already, in the numerator. My k to the third, negative third in the bottom goes up, so that's times a k to the third from the denominator. My m to the negative third goes up as well. And my m to the negative fourth goes down. Simplify what you have. I have 64k to the sixth from a product rule. My m cubed and my m to the fourth can simplify. You can do this using quotient rule, but you will have a negative exponent. You can also just see that you can cancel these values out. You have 3 here, you have 4 here. That would mean you have 1 left in the denominator. So you have 64k to the sixth over m. Okay, so ladies and gents, that concludes this particular lecture. I will be going into the next lecture in just a few moments.